Past couple of days, we've been talking about solving exponential, logarithmic equations. In both cases, we want to convert to the other kind of equation in order to solve. So for example, if we have an exponential equation like this, we can't solve for x until it's down on even ground with all the other numbers. And one of the properties of logarithms that we learned about is the power property of logarithms, and that would allow us to pull that exponent down in front to be a coefficient. But another way to do this is to convert this exponential equation to log format. So I'm going to show you both ways. I'm going to show you how to convert and use the change of base formula. And I'm also going to show you how to use the power property of logarithms. Power, silly. Power property of logarithms. So the power property of logarithms says that if I log this 3, so if I do this, I log the 3, then that frees the x minus 1 to come down front and be a coefficient. It's being multiplied. But if I'm going to log this 3, I also have to log the 72 on the other side, because what you do to one side, you do to the other. So then we have x minus 1 times log 3 equals log 72. From here, we want to work to get x by itself, and so I'm going to divide both sides by log of 3. And when I do that, these log of 3's cancel out, and I'm left with x minus 1 equals log 72 over log 3. So I'm going to take my calculator and actually evaluate what log 72 divided by log 3 is. Log of 72 divided by log 3 equals 3.8928. Now in class we talked about how I'd like you to round no less than 2 decimal places and no more than 4. So I'm going to take 4 here, 3.8928. And I rounded that 4th decimal place up because the next number was an 8. That's still equal to x minus 1. I'm going to add 1 to both sides, so I get my final answer of x equals 4.8928. All of this came out of using the power property to pull this exponent down to the front, logging both sides. If I instead wanted to convert this exponential equation to log form, I would take the base of my exponent becomes the base of my log. So this would be log base 3. My argument is always what my exponential equation is equal to. So I'm going to take log base 3 of 72. And a log equation always solves for an exponent. So the exponent here is x minus 1. We're going to evaluate this log by using the change of base formula. The change of base formula says that for any log with like a weird base that isn't base 10, we can take a common log of the argument and divide it by a common log of the base number. That's going to be equal to x minus 1. Now you'll notice this is a lot less steps, but this right here looks exactly like what this method did right before we solved. So from this point forward, this method is going to look an awful lot like this method. We're going to get x minus 1 equals 3.8928. We're going to add 1 to both sides, and we're going to get our answer. So whether you use the power property of logarithms or you convert your exponential equation to log form and use the change of base formula, these two methods look very different, but they're going to get you to the same result. So that's exponential equations. When we talk about logarithmic equations, there are a few steps to keep in mind. For logarithmic equations, first you need to make sure that all log expressions are on one side or on the same side of the equal sign. So whether you have to add or subtract to get them all onto one side, you'll need to do that. The second thing is you need to make sure the logs are alone. That means you need to use the power property to pull up any coefficients into the argument, or you might have to add or subtract any sort of lingering numbers to get them to the other side of the equal sign. And then the third thing is that we need to make sure to compress all of the log expressions that we have into one log. And that usually requires use of the product property or the quotient property. Once you check to make sure that these three things are complete, we're then going to convert our equation from log form to exponential form. And then finally, we're going to solve for x. I'm going to do a very complicated example here, just to kind of show you all the things that you might have to do. Let's take a look here. So for example, if we had log of 7x plus 1 equals log x minus 2 plus 1, our first step was to make sure all logs are on the same side of the equal sign. So I'm going to move this log by subtracting it. Log of x minus 2 minus log of x minus 2 is 0, so those cancel out, and I'm just left with a positive 1 on this side of the equation. Over here, I'm going to have my log of 7x plus 1, but I'm going to be subtracting from that log of x minus 2. Now all of my logs are on the same side of the equal sign. They're alone. I don't see any coefficients or any extra numbers. It's just logarithmic expressions here. So now I'm going to compress them into one log. The way I do that is I take one log, and my first argument of 7x plus 1 is going to go over my second argument of x minus 2. That's going to be equal to 1. Now that we've condensed this down into one log, we're going to convert it to exponential form. That's going to be 10 to the first power is equal to 7x plus 1 over x minus 2. Now you'll recognize this as a rational equation, and we talked about this in Unit 5. And so what we'll need to do is multiply by the denominator we would expect all the pieces here to have, which would be x minus 2. So we would do the whole entire equation by x minus 2 over 1. That gives us 10 times x minus 2 over here equals 7x plus 1 times x minus 2 all over x minus 2. That allows us to cancel out the denominator. And now it becomes a much easier equation to solve. I'm going to distribute this 10 into both pieces of this parentheses. That makes it 10x minus 20. And that's equal to the 7x plus 1 that's remaining on the other side. I want to get all of my x's to one side and all of my numbers to the other. So I'm going to subtract 7x from both sides. That leaves me with 3x. And I'm going to add 20 to both sides, which gives me 21 on the other side. Then I'm going to divide by 3 and find that my answer is x equals 7. The one thing I want you to notice about this is actually solving the logarithmic equation comes from previous units. The actual act of getting it into solvable form is what's new in this unit, all of this stuff up here. Moving the log, using the quotient property, transforming it into exponential form. All that's new in this unit, but everything that comes after that came from prior units. So it's possible you're going to be required to solve a quadratic equation, a linear equation, a rational equation. Anything that we've done previously in this course is fair game. So if you need review on any of those topics, make sure you stop by and see me.